this session, I'm going to discuss about how to build a network model to classify the given images. As a part of that, first we have to discuss about how to read the images and then how to display them on the screen. Then we can go for the number of images, how to read the number of images, and how to prepare the data set. Once if you prepare the data set, then you can build the model and then train it and then predict for the given image. So we will discuss about all these concepts in this session. So as the part of that, we have Anaconda environment on our desktop or on the machine. So here we have to open this. If you open the Anaconda navigator, you will get the Jupyter. You will get this environment. In this, there are a number of IDs and other services and other tools are available in this. Out of that, I am interested on the Jupyter notebook. If you open the Jupyter notebook, then it will open the Jupyter notebook environment like this. So that here it is the Jupyter notebook environment. Here you can type the programs and you can execute the programs of the on Python environment. So here in this, actually, if you want to create the new notebook, you can go with the new notebook. You can create that. And already I have created and executed the program, and I'm going to explain that. So see here, this is the program what I have executed. So in this, we are taking the data set that is called the shapes. Okay, it is available on the DLT datasets on the desktop. Now let us verify what are those images available. Now I'm going to display them. See here, DLT datasets folder is available. In this, we are getting the datasets like flowers images and shapes dataset. Here I'm going with the shapes dataset. In the shapes dataset, we are having 4 folders. Circles, circles, again shapes is there, squares and triangles. We are interested on the circles, shapes and triangles only. So circles, if you open the circles image, so see here, handwritten circle images are available. If you open it, handwritten circle, it is available here, so that if you display this, yeah, if you make it zoom, I'm zooming that. So this is the handwritten 0, and in the similar way we have the handwritten so many handwritten zeros are there, and handwritten squares, square is also available. And say this here, so this is the square, handwritten square, and in the similar way we have the triangles also. Now what is our task is, we have to accept one image of the one shape, and we have to predict which type of shape is that, whether it is the circle, square or triangle. So for that, first of all, we have to build a model and to train it on the neural network. You have to train the model, and then we have to provide that image into the model. Then we can get the output, which is the name of that particular shape, whether it is the square or triangle or circle. So first of all, I will explain you how to read a single image. Let us say, for example, drawing 1. It is available. Where it is available? See here, in the C drive users BALAR, Balaram name. This is my laptop, so that it is having this, and on that my drive, in that desktop, and DLT datasets, shapes, circle. This is the data available in this. Now in this, I want to get this. Of course, in the same folder, you can observe that again in the shapes, you have the shapes folder. Inside that, I think it is the duplicate is available. So that I'm going to take the shapes inside the shapes. I'm taking this directory. Now we can go with that. Let us start with this. Now, yeah. Now let us open the Jupyter notebook available. So here it is the Jupyter notebook. Yeah. In this, what I'm doing is uh, I'm importing the required libraries, NumPy as NP and then Pandas as PD, and I'm loading the OS module also because I have to access the file system. The files are available in different directories. So we have to open the file, we have to access the file system. So by using the file system, I'm trying to retrieve the particular folder. See here, if you want, you can see that here. Simply you can give os.listdir. It will show you it will show you all the directories available in the current path where we are. And as we know, the shapes dataset is available on a particular path that already we have seen, so that we can go with this. This is the shapes dataset. In this, see here, this is the dataset. Already we are on the Balram directory, user Balram directory. So directly you can give the OneDrive. Inside that there is the desktop. Now you can observe that we are in the Balram directory. In that there is the OneDrive. Here we have the data. So I want to go with that data set. So that how can we go with that OneDrive? So within quotations I can give OneDrive. OneDrive. So in that there is the desktop. So I want to go with the desktop. Inside the OneDrive, I have the desktop. So let us execute. In this, there are so many files are available. Out of that, I am interested on the DLT dataset. The datasets are available in DLT datasets. So I am giving that DLT datasets slash DLT space datasets. So inside that there is the flower images and shapes. From that I want to go with the shapes. Again inside that there are the circles, shapes and others are there. So I'm going inside the shapes. Again I'm going inside the shapes. Right. So here inside that there is the circles, squares and all. So inside that I want to go with the circles. See here, this is what we have done. Circles, so that we have the number of files available, drawing1.png and all. So I want to display this. Now for this, only to explain this, I have added this cell. I'm deleting this. Now we have that list dirs of shapes. Up to that we are having this. Inside that we have the shapes. Now what I want to go with is list dir of shapes slash, again I want to use shapes. Inside that there is the circles. So I want to get that first 5 records. Colon 5 means actually it returns the list. Out of that list I am taking the first 5 file names. These are the first 5 file names. Okay, and then I want to get the squares also. From the squares I want to get the first 5 file names of the squares. So in this way we can access the files by using the Python program, by using the OS library. Now let us open the image and display it. So see here, for opening the image we have different libraries. We have the matplotlib as well as the PIL. So matplotlib, by using the matplotlib as the basic, we can use the matplotlib to import the to load the image and display. So import matplotlib.pyplot as BLT. This is for basic graphics to display on the screen. You can display, you can create a graph, you can plot a graph, and you can display the image. Whatever is the graphics related, that can be displayed and that can be performed by using the matplotlib.pyplot. And from the matplotlib.pyplot, again I am importing the image module. So by using this, we can load the data set, we can load an image and display it on the screen, and we can perform some operations of the image. Now I'm reading the image from the squares directory. So as we have seen, this is the directory available squares. From the squares, we have number of drawings available, drawing 1, drawing 2, drawing 55 is also there. I'm taking that. So how can we read that? That is by using im equal to image dot im read. This is from the matplotlib. Please remember this. Im read is from the matplotlib. So it will read the image, and how it is reading the image, that is by using the to know that what is the type of im. Type statement is available, which will give you what kind of object it is, whether it is the integer object or numpy object or it is a data frame, which type of object is that will be displayed by using the type statement. So here type of im. So im equal to image dot im read of image name, image path, full path, and then type of im. So it is numpy dot nd array. It is reading as the array. Please remember that the image can be represented in the form of the image, in the form of the numpy. Okay, numpy array. Here the image means it is a collection of pixels. Pixels, there will be the number of rows and columns. Rows and columns, they are the intersection of the row and column, that is called the pixel. The collection of pixels arranged in the grid, that is the image. So how can we access that? How can we see that image? First of all, let us display the image in the image form and then display in the numerical form. Now let us see that here im.shape. What is the shape of the image which we have read? That is the 28 by 28 by 3. It is the 28 by 28 means 28 rows, 28 columns, that is the number of pixels, and then the 3 means RGB. 3 layers are there, RGB. Okay, so here plt.im show of im. This is to display the image. I want to display whatever you read, that I want to display that. So we can display the image. See this here, this is the image displaying. Here 0, 1, 2, 3, 4 pixel number, pixel rows. Here this is the rows 28 up to 28, and 0, 1, 2, 3, 4 up to 28 it is there. So that here this is the square. You can observe that this is the square. You can find the small block. This is called the pixel. See here at this place also there is pixel. That pixel is having the white color, and this pixel is having the dark color, that is the black color, and this is having the dark gray. This is the gray color. This is the light gray. This is a very light gray, meaning that there is the shade difference in the each pixel, so that we can easily identify the shade to form the shade. Now how it is representing? It is the image representation on the graphics form. And how can we represent the same image in the numerical form? See this, I am displaying the im, so that it is displaying the last. What is the shape here? Actually it is the 28 by 28 by 3, so that we are seeing from the last dimension. From the last dimension there are 3 means there are 3 values in each element, and the how many are there? Total 28 will be there, like this. This is 1, this is 2, and this is 3, and so on up to 28. 28 rows are there, and depth is again 28. See here, like this, how many will be there? Is this is one set, this is one set, this is one set, like this. Total 28 will be there, meaning that 28 by 28 by 3. Now I want to display, actually it is showing like this. Actually it is showing like this. Now this is the first element of the last dimension, second element of the last dimension, third element. 0, 1, 2. These are the elements. Now I don't want to see from this side. I want to see from this side. I want to see this dimension. Actually, this dimension I am seeing only three elements. If I see this dimension, I will get 28 elements I can see. So I want to see only this dimension of only one layer, meaning that in 0, 1, 2, I want to see only one layer in this dimension. To do this, I want to open this, see here. This we cannot understand. Now I am seeing that IM of column means all the rows, 28 rows, and column means all the 28 columns, and I want to see only one layer. Actually there are three layers. If you display IM, those three layers are displaying like this. I don't want to see that. I want to display from this, and I want to see only one layer. So for that zeroth layer, I am seeing the zeroth layer. It is displaying like this, 28 by 28, but it is not showing properly. So I want to actually up to here it is displaying, and I want to display all the elements in the single row, meaning that one row should be displayed on the single row, second row should be in the second row, like that I want to. Now how can we get this? That is by using, see here, I want to set the display for this purpose. How can we display that? That is, see here, np dot set print options of, this is the numpy object property. We can set this, set print options of line width equal to np dot inf. So infinity, I am making the line width as the infinity so that it can display all the elements of the same row on the same line. So that I am just setting that property, and then I am just displaying np dot print. I am just printing im of colon 0, the same thing, but I want to round this. Actually there are so many decimal places. I don't want to display all the decimal places. I want to take only 2 decimal places. No, I want to take only 1 decimal place, meaning that round it to one decimal place, so that I am rounding that np dot round of this image, this is this what I am giving, and rounding to 1 digit, so that I am getting this. So see here, you can observe all are ones. The white color is represented with the ones, and the black color is representing with 0. If anywhere if you get the complete 0, then it is called the complete black. See here, 0.6 it is the gray color, 0.3 dark gray color, meaning that almost black, and 0.4 it is the dark gray. This is also the gray color, this is the dark gray, and this is the white color. So that if you observe that this is showing that as the shape, this is showing as the rectangle shape. This is how the image will be represented in the numerical format, and this is the first row, first layer. This is the first layer I am showing, and this is the second layer I am showing. I just want to show the second layer. Here we have to put 2. Here we can put 2, so that we can get the image. So we have to read. Actually I have not executed all this, that's why it is giving the error. I am executing all of them again, so that, yeah, 1 and then 2. See here, this is the 2. Okay, and then I want to display this. I want to display IM show. By using IM show, I want to take only one element, meaning that one layer, and I want to store that into IM1, so that I am taking that IM1 equal to IM dot mean of. I am taking the mean of 3 layers, so that I am getting only single layer, and we can get the single layer image. So that I am trying to display on the screen by using the IM show. Even if it is having the single image, single layer, by default it will take that two other layers will be taken as the default values, that may be 0 or 1, so that it is showing that in the different color. But you need not think about that. It is taking only single layer we are saying that. And if you display that in the gray format, that is CMAP equal to gray, as the additional parameter so that you can display on the screen. So this is what how to display how to read the image and display on the screen. So in this session I want to explain this concept how to read the image. In the next in the continuation to this session, next session I will explain how to read the number of images and how to prepare the data set. Thank you.